Alright, so today shouldn't be too bad, hopefully. It's on what's called inductive, deductive reasoning. So they both use this word called a conjecture. Which is an unproven statement based on observations. So it's kind of like a conclusion. See see something, and you say, "I think," whatever. Okay. So I'm gonna define deductive reasoning first, and then, to be honest, we won't really use it today, but we will use it in the future. Deductive reasoning uses facts, definitions, properties. There's some other things, but to make conjectures. So what we're going to use in a few days is this idea of using some definitions and properties, theorems, postulates that we use in geometry. Alright, so inductive reasoning uses patterns for the most part. Patterns and observations to make conjectures. You could almost substitute the word conclusion for conjecture. So you'll have some that are very simply what are the next two numbers in that sequence. So you look for a pattern. Well, that goes up 1, then up 2, then up 3, then up 4. So we could say up 5 and up 6. So to do that, you've just used inductive reasoning. Okay? So you'll have, like I said, some that it's a sequence of numbers or letters or figures, and you're just supposed to do the next two in that sequence. Okay, so then you'll move on to some problems that it'll say make a conjecture, or so you know what, I take that back. It's going to say make and test. Make and test a conjecture about the sum of three consecutive integers. So if you add up three numbers in a row, it's another way of like saying that. So 1 plus 2 plus 3, well, that would equal 6. And so what you want to do for this is just come up with 3 or 4 different examples, and then we're going to try to see if we can find like a shortcut kind of thing. So if I did 6 plus 7 plus 8, that would be 21. So I did 11 plus 12 plus 13. That would be 36. And you could have some overlap. So like this has 6, 7, 8. I could have 7 plus 8 plus 9. So it doesn't have to be just 3 completely different numbers. But the idea is, I've got these 3 numbers, and it said make and test a conjecture about the sum. The sum is the answer to an addition problem. So is there a way without adding the numbers together to know what the answer is going to be? And so there's really not like a step 1 do this, step 2 do this kind of thing. So it is just a matter of looking at it and making an observation and then saying, oh, I think it's this. So maybe pause the video and look at that for a minute, and see if you can come up with something. But really, if I did the middle number times 3, so the answer, if you will, would be multiply the second integer by 3 to get the answer. So there could be another way to like look at it. It's not like there's only one right answer to some of these. So just do the best you can to see if you can make an observation, and if you can't, then you can't figure it out, just ask, and I'll kind of give you like one way to like look at it. Okay. Then the last set of problems will be using what's called a counter example. And it's an example to prove a conjecture false. So it's much easier to come up with an example to show something's not true than it is to absolutely prove something is true. Because you might be able to come up with a bunch of different examples that show that something is true, but it only takes one to show that something is not true. So if you had a conjecture that said the sum of 2 numbers is always more than the greater number. So what it's saying is, if I had 2 plus 3, well, 5 is bigger than 3. The bigger number is 3 of the two. 5 is bigger. So, 4 plus 7 equals 11. Okay, 10 plus 12 equals 22. So there's 3 examples where 5 is bigger than 3, 11 is bigger than 7, 22 is bigger than 12. I could go on all day doing this. But could you come up with an example where it's not true? And then would be a counterexample. So what if I did negative 2 plus negative 3? That would give me negative 5. And the greater number in this problem is negative 2. And it's not bigger than negative 5. So basically, if you used negative numbers, or at least one of them is a negative number, then that would be a counterexample. Okay, so it'll give you a statement, and then you need to come up with an example to show that that statement is false. Okay, and there, in a lot of cases, there are more than one example, like counterexamples. So if you checked your answers in the back of the book or on the website where I post the answers, you're going to find the word sample answer, and then it gives you something, and that just means there's other answers to that as well. Okay? All right. So hopefully it's not too many problems today. I think it's 3 to 16, so it's not terrible, but have a great rest of your day, and we'll talk to you tomorrow.